Hello everyone, myself A.Yadagiri, Assistant Professor, Department of EEE. I'm also the Faculty of Basic Electrical Engineering. In the last session, we have discussed about the analysis of the RL series circuits. So in that, we have discussed about the impedance of the circuit and also the inductor reactance of the circuit and also the instantaneous value of voltage and also the instantaneous value of current. And based on that, how much amount of instantaneous power taken by the RL circuit, and based on that, also we have determined the average power consumption of the RL series circuit over a complete cycle. We have discussed in the last session. So in this session, we are going to discuss about the analysis of the RC series circuits. So RC series circuit means we need to take a resistance of R ohms and also the capacitance of the C farad we need to take. So based on that, we need to make a circuit like a RC series circuits. So in that RC series circuit, we need to discuss about the what's the RMS value of voltage and also the RMS value of current and also how much impedance offered by the RC series circuits. So based on that one, how much amount of power factor taken by the circuit, and also based on that, we need to find out the average power consumed by the RC series circuit. So we need to discuss these many things in this session. So let's discuss about the this RC series circuit right now. So in this, we need to take a resistance of the circuit is R ohms and which contain in series with the capacitance of C farad and which are supplied from an alternating voltage source, that is a V, and which drives the resultant current as capital I. So here we need to take the both quantities are in terms of the RMS only. So here we can say V is the RMS value of voltage. V is the RMS value of voltage. And capital I we can call it as the RMS value of current. It is a RMS value of current. So it is a capital I. So this one we can say VR means VR is the voltage across. This one is a voltage across the resistor, and the other one is voltage across the capacitor. So we need to write the same things are here the voltage drop across the resistor, voltage drop across the resistor. So that is we can say VR. So when we can expand that in terms of the Ohm's law, that is I into R we can say. So in terms of Ohm's law, we can expand that equal to I into R. And then other also there, that is other parameters of VC means it is a voltage drop across capacitor. So previously it was a VL means voltage across the inductor, that is in the previous case. So in this case we can consider the VC as the voltage drop across the capacitor. Voltage drop across the capacitor is a VC. So that is a VC equal to, according to Ohm's law, it is I into XC. So VC value is a I into XC. So all are the phasor notation only, that is V is the phasor notation of the applied voltage and the resultant current is IRMS, also the phasor notation, the phasor parameter, and the other one is VR is also the phasor of the voltage across the resistor, and this one also phasor of the voltage across the capacitor. So based on these phasor quantities, we need to draw the phasor diagram. So based on that only, we need to analyze the current of the circuit. So we are applied the voltage to the RC series circuit. Based on that, we will get some amount of current in terms of RMS. So for that, we need to draw the phasor diagram with the help of these all the phasor parameters like phasor quantities. So need to draw the phasor diagram of the above RC circuit with phasor diagram of the RC circuit. So with the help of what it is a VR, VC and I. So while drawing the phasor diagram, so we need to consider the reference vector as a IR or the reference phasor as a I. So means it is the constant value. It maintain always constant. The current should be the throughout the circuit is a constant. So that we need to take the I as a reference. So this is the current vector we need to consider as a reference. So this is the current vector we need to consider as a reference. So with reference to the current vector, so the voltage across the resistor, should be in phase. So how would I say means? So this is the current of the resistor. So this is I we can say. So then the voltage across the resistor is a VR. So this voltage and currents both are in phase. Both are in same phase. That's why there is no phase angle difference between these two. So this is the phasor notation of the pure R case. So if it is a pure capacitor, so this is the current is a reference one. This is the I, and with reference to the current, the voltage across the capacitor should be, so that is a lags behind the current at an angle of 90 degrees. So it is already discussed in the pure capacitor case. So we need to merge these two into the single phasor diagram. That is a phasor representation of the, so this RC circuit. So with reference to the current, the voltage is in phase in case of resistor. This is the VR. So with reference to the current, the voltage across the capacitor. So we need to join the capacitor voltage, capacitor phasor with the resistor only. So based on that, we need to take the voltage across the capacitor is at this point. This is the voltage across the capacitor. The voltage across the capacitor according to this single one. According to the pure capacitor. So it's always lags behind the voltage at an angle of 90 degrees. So this is VC. So the angle difference between these two should be 90 degrees. So VR and VCs are the phasor sum. Or the VR and VCs are the vectors. So based on that, we need to draw the summation of two phasors. So this is a VC. So we can say it is a VC. So the phasor sum of the VR and VC called applied voltage. So this is the applied voltage. So need to take the other color to draw the resultant vector. So for that need to take this. So this is the applied voltage is a V. So we need to assume here this is the point O and this is the point A and this is the point B. So need to plot the phasor diagram of the RC series circuit with the help of VR, VC and also I. So it is a way of representing the, it is an easy way of representing the electrical parameters in the mathematics to analyze the required things are easily, so that we can go through the phasor diagram. So based on this one, this is the phase angle between the voltage and current is a phi, we can say. So this is a point O, this is a point A, this is a point B. So from the phasor diagram, so need to analyze in detail, need to analyze further to get the required current value of the circuit. So from the phasor diagram, according to the Pythagoras, from the right angle triangle OAB, from the right angle triangle, according to the Pythagoras, so we want to write the value of the OB square equal to the OA square plus AB square. So according to the Pythagoras, from the right angle triangle of OAB, so that is OB square equal to OA square plus AB square. So the OB means we can say to be as a V square, then VR square, then plus VC square. So this is the VC. AB value means VC only. This is the VR. So this is the V. So the OB value, OB square equal to the OA square plus AB square according to the Pythagoras, we can say. So we can also write in terms of the Ohm's law. That is I into R whole square plus I times of XC whole square. So because we have already determined this one and this one also. So substitute the same values here. So we will get exactly the voltage of the circuit should be. So this is the I of R square plus means I square plus XC square. So need to write the current is, need to write the current value separately. So for that V equal to I of, that is a square root of R square plus XC square. So here this is the I value. From this one, the exact current flows through circuit, that is a V upon square root of R square plus XC square. So this term we can say, so the term here we can control here the term. So square root of R square plus XC square is always opposing the flow of current. Is always opposing the it is always opposing the flow of current. So it is we can flow of current. So we can simply call it as this whole term is, it is the impedance of the circuit. So because it's going to oppose the flow of alternating current, combinedly oppose the flow of alternating current. So that it's combinedly we can simply call it as impedance of the circuit. So it is known as, or it is called as impedance of the circuit. So it is the impedance of the circuit. So that is we can represent by the capital Z. So this is the impedance of the circuit. Impedance of the RC circuit is the square root of R square X square. So where Z equal to then square root of R square plus XC square. So then we can simply find out the overall current circulating to the RC circuit. So this is the overall current circulating into the RC circuit is a I equal to V by Z, where Z is the impedance of the circuit, so which offers the opposition of flow of alternating current, that is R square plus XC square. So this is the magnitude value of impedance. So it's also we can use in the numerical to get the material impedance or the circuit impedance. So this is the current value. And also we need to find the from the phasor diagram. This is the phasor diagram. So from the phasor diagram we also find the phase angle of the circuit. So for that we can say phase angle. The phase angle always saying about us, it is the angular displacement between the two alternating quantities. So one alternating quantity is a voltage and other alternating quantity is a current. So it's simply saying us about the phase the angular displacement between the two alternating quantities. So that is clearly saying us the current of the whole circuit is always leads ahead the voltage in an angle of 5 degrees. So same we can conclude here. So the current of the circuit, so the current of the circuit always, I mean to say the current of the circuit always so leads the voltage by the angle of by an angle of 5 degrees. So leads the voltage by an angle of 5 degrees. So that is leads the voltage capital V, because it's RMS, leads the voltage an angle of 5 degrees. This is the phase angle. So from this one we also wanted to find out the phase angle value. So further we need to take again the right angle triangle OAB. So from the phasor diagram we need to take the right angle triangle OAB, this one and this one. So based on this one we need to write the tan pi value, the tan theta value. So tan pi equal to, so according to this one we need to write the tan pi value is so it is opposite side upon the adjacent side. So based on that opposite side is it is AB upon OA. So AB is the here the VC square upon VC square upon VR square. So we also going to take here the right angle triangle. So this is the point A and this is the point O. So and this one is this one is a point B. So this is the VR, we can say it is the angle phi, and this one is a VC, and this is the applied voltage of V. So from this right angle triangle, so we want to write the tan pi value. It is a opposite side upon the adjacent side. Based on that we'll get VC square upon VR square. So therefore the tan pi, so we are going to expand this term with the help of Ohm's law. So that is the I into XC. Sorry, it's not a square, it's only the VC upon VR. So then I into XC upon the I into R. So both are gets cancelled. So which implies tan pi equal to XC upon R. Then the phase angle of the corresponding RC circuit is a tan inverse of XC upon R. So this is the phase angle of the RC series circuit. So till now we are also determined, we have determined about the applied voltage of the circuit, and based on that how much amount of current circulating, that is in terms of RMS equal to the V by Z, and based on that we also determined the impedance of the circuit, so which offers the opposition of flow of alternating current. So based on that how much amount of phase angle maintained by the voltage and current of the circuit, that is a phi. So phi equal to tan inverse of XC upon R. So then after this one we need to draw the voltage and current waveforms. So before going to draw the voltage and current waveforms, we need to take the instantaneous power. So the instantaneous power taken by the RC series circuit, instantaneous power taken by the RC series circuit. So that is a P equal to so V into I. So V means it is a Vm sin omega t, is a sinusoidal voltage. Then I is a Im sin omega t, it's a plus phi. So previously it was a minus pi. So because the current of the RL series circuit always lags the voltage at an angle of 5 degrees. So in this case the current of the RC series circuit always leads ahead the voltage at an angle of 5 degrees. So this is this one, and we need to do some mathematics here. For that Vm, then Im here. So sin omega t into sin means omega t plus phi. So we need to do some multiplication here, that is with the help of 2 and 2. So we will get the Vm then Im by 2. So it is a 2 times of sine omega t into sine of omega t plus 5. So the whole term is looks like a 2 sine a sine b. So the formula of 2 sine a sine b, so the formula of the 2 sine a sine b is the so cos of a minus b and also the cos of a plus b. So based on that we need to write the values of, so this one it is looks like a 2 sine a sine b. So 2 sine a sine b. The 2 sine a sine b formula is in terms of in the trigonometry. So there is a cos of a minus b then minus cos of a plus b. So this is the formula. So based on this we can expand this one. So therefore the power, instantaneous power taken by this one, so Vm Im by 2. Then this one is we can write in terms of, so in the bracket we can take then cos of, so here this one is we can assume like a and this whole term is going to treat as a b. So we can apply, we can substitute this a b values in the formula. So for that omega t minus omega t minus 5 we got here. So then minus of, so cos of minus of cos of again omega t, omega t plus omega t plus 5. So here both gets cancelled and so here Vm then Im by 2. So we got here cos of minus 5. So cos minus 5 or cos minus it is a cos theta only. So for that here the cos of 2 omega t plus 5. So this the resultant term we will get based on the some the mathematics. So overall the instantaneous power taken by the RC series circuit is a Vm Im by 2 cos 5 minus then Vm Im by 2 cos of, so 2 omega t plus 5. So the instantaneous power so taken by the instantaneous power taken by the RC series circuit is this one. So the instantaneous power has the two parts. One is the constant part, other one is the pulsating part. So pulsating also we can say variable part. So because it's vary with respect to time, so that's why we can say it's a variable part. There is no time constant here or there is no time function here. So that it's we can conclude as a constant one. So the variable part of the instantaneous power over a complete cycle should be 0. The average power and the average value of the variable part or the pulsating part over a complete cycle should be 0. Why? Because it's a cosine function of the double frequency. So for that the average value will become 0 only. So like that we will get the waveform. So based on that, so we will get the average power of that one is 0. So the average value of this one is 0 and also the average value of this one is 0. So for that the variable part of the instantaneous power should become 0. So therefore the average power taken by the RC circuit, so P average equal to the, so that is a Vm then Im by 2 into cos 5. So over a complete cycle, so this value completely 0. So based on this we will get only the average power taken by the capacitor should be this one. So that is a P average equals to, we can simply written as, so Vi cos 5. Means it is written in terms of the Vm by root Im by root 2, that is a Vrms into Irms. So simply say it is a Vi cos 5. So this one we have already seen in the pure resistive case and also the RL series circuits. So because of the presence of the resistance in the RC network, so it has to consume some amount of active power to compensate the power factor or to improve the power factor of the system. So based on that the average power consumed by the RC circuit because of the resistance, that is a Vi cos 5. So that value also we can determine here. We have concluded this one is so due to the resistance only it has to consume some active power. So that is Vi cos 5. So we need to find the resistance power. The consumption of the power taken by the resistor is V equal to, we need to say I into Z, then I keep as it is according to the power factor of the system, that is R by Z from impedance triangle. So both these are going to get cancelled. Finally P equal to I square into R. So the power dissipated by, or the active power taken by the resistor is I into R or V into I or I square into R. So based on the resistance only there will be active power consumption taking place in the RC network. So that is this one. So next we need to draw the instantaneous voltage and currents of the network. So the voltage and currents of the network. The voltage and current waveforms of the network. So this is the applied voltage. It starts from 0 and this raised to the pi, and other one is a 2 pi. Then this one we can write already denoted here, V equal to V max sin omega t. Then current of the RC network always leads ahead that, leads the voltage at an angle of 5 degrees. So previously if it in case of a pure capacitor, so the current is always leads ahead the voltage at an angle of 90 degrees. It is a V and it is a I. So this leading angle of the current has to reduce it by 5 degrees. So because we have added the resistance to the capacitor, that's why. So the power factor angle should be improved. So based on that one, the current should be starts from the some angle. So with reference to the voltage, it always leads ahead that at an angle of 5 degrees. So this is the voltage and currents of the RC series network. And the last one is the power factor we need to take, and the power factor of the RC series circuit. So that is a power factor. So power factor of the RC series circuit. So power factor we can define from the impedance triangle. So the power factor of the RC circuit is, so we know that Z equal to R plus JXC. So from the impedance triangle we need to take, so this is the impedance triangle of the RC series circuit. So this is the impedance triangle of the RC series circuit. Then so this is a Z and this one is a R, we can say, and this one is a XC it is. So based on this one, from the right angle triangle OAB it is. So this is the phi we can consider. Then from this one, cos function should be, so that is R by Z. So the power factor of the RC series circuit is a ratio of the resistance upon impedance. So this is the power factor of the RC series circuit. Based on this one we have determined the active power taken by the circuit should be, so that is equal to VI cos phi. So instead of the V we can treat it as, we can substitute it as V is IZ, then I keep as is equal to the power factor notation. Then cos phi should be the R ratio of the resistance to impedance. Both are gets cancelled. So finally P equal to I square into R. So this is the active power or power taken by the average power taken by the capacitor RC circuit. So next one, the phasor representation, and also the overall phasor representation or the phasor diagram of the network, and also the power curve. So with reference to the voltage, the current is always leads at an angle of 5 degrees. So or with reference to the current, the voltage is always lags the current at an angle of 5 degrees. So both terms we can conclude the voltage and the phasor notation between the voltage and current. Either the reference with the voltage, the current is leading. So either the reference with the current, the voltage is always lagging. So anything we can consider, then either the voltage as a reference or the current as a reference. So based on this one, just now we have seen about the voltage and current waveform. So this is the applied voltage. So this one we can written as a V equal to Vm sin omega t. Then current is always leads ahead that. So this is the leading angle of current. So this much amount of leading angle maintained by the current due to the resistance. So that is a phi with the resistance and capacitor, that is a 5 degrees. So that the corresponding current should be I equal to then Im sin of omega t. Its leads means plus phi. So then this is the instantaneous power. This is the instantaneous power. So combination of both voltage and current only, because it's active power only. So combination of these two. So this is the instantaneous power taken by the RC series circuit. So in the whole RC network analysis, so till now we have discussed about what is the RMS value of voltage, and based on this one, how much RMS value of current we have obtained, that is V by Z. So for this, Z is always opposing the flow of alternating current. So hence it is called impedance of the circuit. So Z is, we can simply say, impedance of the circuit. So the value of Z is in terms of RC network, that is R square plus XC square root, because it's a phasor notation or the phasor quantity. That's why we can take it as always the magnitude value. So that's square root of r square plus xc square. And after that we have also determined the phase angle of the voltage and current, that is a pi equal to then tan inverse of, so here vc upon v, or we can say tan inverse of xc upon xr, both we will get same. So after that we also determined the average power taken by the RC series circuit. So that should be Vi cos phi, that is none other than active power only. So that is the average power taken by the RC series circuit. Based on that, we have also plotted the phasor diagram between the voltage and current. So with reference to the current, so the voltage always lags behind that at an angle of 5 degrees. So this is the phasor diagram of the RC series circuit. So then after that, we also determine the power factor of the this one. So that is R by Z. The power factor of the RC circuit should be R by Z. So these many things. So we have discussed till now in this session. So this is the end of the session. Thank you one and all for the watching of the session. So in the next session, we are going to discuss about the analysis of the RLC series circuit. So this is the end of the session. Thank you one and all.